Rapidus has finally named its price. For 2nm contract manufacturing, the company is looking at 3 to 3.5 million yen per wafer, roughly on par with TSMC, or slightly below. But I can't simply celebrate this announcement. The yield is still invisible, and yet the price came out first. In my view, that ordering, price before yield, is exactly where Rapidus's real challenge shows itself.
Hello everyone, I'm Ty, with 31 years in the semiconductor industry. Today, starting from the reference price Rapidus has put on the table for its 2nm process, I'll explain what numbers really matter behind a wafer price and what customers are actually waiting for, all from a practitioner's point of view. By the end of this video, you'll know exactly what to look for when you read the next piece of Rapidus news. Let me start with an analogy. Imagine a huge new bakery being built in your town. Its goal is to bake premium loaves at the same level as a world-famous overseas bakery, the kind that restaurants around the globe line up to order from. And the other day, this new bakery, still preparing to open, made its very first announcement: the price. Our price per loaf will be the same as that famous bakery, or maybe a little cheaper. Now, how would the restaurant owners react to that? An affordable price is welcome, of course, but what they really want to know is something else entirely. Can this bakery actually bake? Premium bread is genuinely hard to make, and some portion of every batch that goes into the oven may come out unsellable. So what matters isn't the list price per loaf, it's what each sellable loaf actually costs, once you count the failures. There's one more thing the restaurants care about: the whole workflow. The famous bakery has a polished system built over many years: how to place orders, a consultation desk for custom recipes, quality guarantees on every batch. And then there's the matter of contracts. When a bakery that hasn't opened yet says, "We're in talks with 60 restaurants," that carries a very different weight from one restaurant has signed a formal supply contract. The former is expectation. The latter is a track record. From here, let me explain concretely how this simplified story is actually unfolding in the real industry. According to Bloomberg, Rapidus President Atsuyoshi Koike indicated that the company plans to set a reference price of 3 to 3.5 million yen per wafer for its 2nm contract manufacturing. That level is said to be pitched at parity with TSMC's 2nm offering, or slightly below it. Rapidus is a young Japanese company aiming to mass-produce cutting-edge 2nm semiconductors in Chitose, Hokkaido, with volume production planned to start in 2027. Its rival, TSMC, is the Taiwanese giant of contract chip manufacturing, the company that handles the vast majority of the world's advanced semiconductor production almost single-handedly. So this announcement means Rapidus is stepping up to match them head-on price. The customer pipeline has also been reported. Rapidus is currently in discussions with more than 60 companies and has already presented rough quotations to about 10 of them. In addition, the PDK, the basic design data package that customers need, began shipping to early customers between February and March of this year. The base of the sales funnel is steadily widening, you could say. At the same time, the hurdles to winning customers have been pointed out. TSMC has an enormous ecosystem: design tools, proven design assets, a mass production track record, advanced packaging, and customer support. Rapidus will need to demonstrate not just an attractive price, but genuine ease of use, all the way from design to volume production. Now we get to the heart of it. The headlines are all about taking on TSMC with price. But what caught my attention was the opposite. Over this past month or so, the only genuinely new piece of important information has been the price. Progress is real, yes, but the information customers most want to see still hasn't appeared. That's how I read this. So what is that most wanted information? As the bakery story suggested, what matters to a customer isn't the price of one wafer, it's the cost per good chip. A single wafer yields a large number of chips, but if the yield, the percentage that come out good, is low, the effective cost shoots up. Until the yield becomes visible, customers simply can't calculate their true cost. From my years in the field, here's the order I believe things should happen in. First, the PDK matures, then the IP lineup comes together, then customers prototype their chips, then yield and performance become visible, and only at the very end do you judge price competitiveness. This time, it looks like that very last item, the price, is the only thing that has become concrete. I understand there may have been business reasons. You need a reference price to move negotiations forward, but the ordering does concern me.
What I'm watching most closely is IP, the pre-built circuit blocks that customers incorporate into their designs. Standard cells, SRAM, high-speed interfaces for moving data in and out. Without these, customers can't design practical chips. Collaborations with major design tool vendors like Synopsys and Cadence have been reported, but the full picture, which IP finishes validation when, and what's actually ready for production design, still isn't visible. Let me organize this. There are 5 things I want to know. Who are the actual customers? Have any customer products reached tape-out, that is, design completion? Are the PDK and IP mature enough for production-level design? How far has yield improved? And has a volume production contract been signed? Of these 5 questions, how many were answered by this latest report? Honestly, not a single one. To be fair, in discussions with more than 60 companies is by no means bad news, but talks with 60 companies and a tape-out by one company carry completely different weight. Discussions are the stage of expectations. Tape-outs and production contracts are the stage of results. What I'm waiting for is that one report with a real company name in it. Company X has taped out a customer product on Rapidus's 2nm process. President Koike has indicated that some kind of announcement from the customer side should come in the second half of 2026. In other words, the next 6 months are the real test. Will we hear more of still negotiating with 60 companies, or specific customer names and concrete results? In my view, this will be the first watershed that determines how Rapidus is judged. Let's think about what this means for Japan. Rapidus is a major national project with government backing, but I believe support is needed not only on the factory side, but on the user side as well. Concretely, build a Japanese version of MPW, a scheme where multiple designers share a single wafer so they can prototype cheaply, and have the government subsidize prototyping costs for universities and startups. Only when the makers and the users grow together as 2 wheels of the same cart does this become a real industry. If a cutting-edge manufacturing base takes root in Japan, that's a genuine plus for Japanese design houses and for equipment and materials makers, a nearby option they never had before. On the other hand, if time passes without customer wins, the scrutiny of this massive investment will only grow harsher. That's exactly why the next news we need isn't another price update. It's real customer names and real results. That's my view. Let me summarize. Rapidus has set a reference price for its 2nm process at 3 to 3.5 million yen per wafer, stepping in at parity with TSMC, or slightly below. But a customer's true cost is decided per good chip, and the yield that determines it is still invisible. What deserves our attention isn't the next price headline, it's tape-outs and production contracts. I'll be watching for those customer-side announcements in the second half of 2026. That's all for today. I'll keep bringing you semiconductor news and analysis, so if you found this useful, please like, subscribe, and I'll see you in the next video. This has been Ty on Semiconductor News Decoded.